Hello and welcome to the AOPA Air Safety Institute's safety webinar, Drone Safety, Real World Risks and Rewards. My name is John Collins and I'm the Manager of Aviation Safety Programs for the AOPA Air Safety Institute and your host for this webinar. Just a few housekeeping items before we begin. Please make sure you've muted your microphones, and if you have any technical issues during the broadcast, we won't be able to actually troubleshoot those for you, but we have found that if you log out and log back in, those issues are generally resolved. We will take questions throughout the presentation and answer as many of those as we can before the end of the webinar. Just use the question mark on your PC or laptop control panel located on the right side of your screen, or the question mark at the top of the screen on your tablet or smartphone to submit those. Our webcams will be available throughout the webinar. For those of you on computers and tablets, will appear either at the top of your screens or to the left or right, depending on how you have it set up. And if you're watching this on a smartphone, you may need to swipe left or right to view the webcams. A recording of this webinar will be available on the Air Safety Institute webpage, www.airsafetyinstitute.org, and you will receive an email with a direct link as well. If you've missed any of our other webinars, you can find those at webinars.aopa.org. And so before we begin, we'd like to do a quick poll just to kind of check our audience and see who we have on the webinar with us today. We'd like to know what your aeronautical experience is, so please select the answer that best describes your flying. Okay. We'll keep this open here for about 30 to 45 seconds. While that's going, I'm going to introduce the folks you see before you. Moderating our webinar today is ASI Senior Director Paul Darris, and joining Paul is Jim Moore, our editor of AOPA Drone Pilot Newsletter, an active remote pilot and an airplane pilot, and Steve Rhode, a public safety pilot in airplanes and unmanned aircraft systems, and the creator of ReportDroneAccident.com website. Welcome, gentlemen. I'm going to close the poll here. I think we've got about 82% of you guys have voted. Go ahead, close that, and I'm going to share the results with you all. So thank you very much for answering that. Looks like the majority of you on the webinar today fly both manned and unmanned aircraft. Very good. Small minority don't fly anything yet, and yet is the operative word there. So hopefully you'll get into the air. And then about a quarter each of you fly unmanned or manned aircraft. So thank you for joining us. Really appreciate you doing that today, being with us, part of the FAA's Drone Safety Week. Paul, I'm going to switch it over to you. You have the controls.
All right, thank you, John, and thank you, Jim and Steve, for joining us for this important presentation today. And thanks to all of you for joining us today for this presentation. If you're on the East Coast, I know it's during lunchtime, but hopefully you'll be able to watch this during lunch. So poll results, yeah, good mix of results in the poll. Both, looks like about 45% both manned and unmanned. So there are some parallels we're going to draw today throughout the discussion between manned flight and unmanned flight. And hopefully over time, we'll see that the poll results change to where more of the manned pilots become unmanned pilots and vice versa. So thanks again and welcome to today's show. All right, let's go and dive right in. Got a lot of material to unpack today for you. First off, today's presentation is part of the National Drone Safety Awareness Week. You may be aware of this. The FAA has been pushing out notices to social media and their channels, so there may be other events taking place this week on this topic. This presentation today, our goal is really to offer some real-world insights and best practices for how to operate drones safely. And we're going to borrow a little bit of the PAVE acronym. To those of you in manned operations are familiar with this from the FAA. PAVE stands for pilot, aircraft, V for environment, and E for external pressure. So we'll talk about that framework and how that can be a good foundation for us today for today's discussion. Both Steve and Jim will be unpacking a few drone accidents for us and looking at those to see what went wrong. And our goal really is to help you build a positive UAS safety culture for whether you're doing this as an individual or part of an organization. All right, so let's start off with the pilot. Am I ready? So keep in mind that drone pilots are not required by FAA to have a medical, but we are required by Part 107 to be sure we don't have a condition that we know of that would keep us unsafe to operate drones safely. The ability to self-assess yourself will develop over time, and we discussed this during some practice session this week. Is even with fixed wing pilots, we're very eager to get into the aircraft and in this case, operate that drone for the first time. And your first few flights will be very exciting. And you think that medically speaking, healthy, you're excited, and that can tend to overshadow any conditions you may have that may be preventing you from flying safely. But over time, as you experience, if you gain experience, you'll find that self-assessing yourself as far as your readiness and safety to fly will develop over time. And human error does result in the majority of accidents, and this carries over from manned flight. We see that about 3/4 of the accidents in GA are a result of poor decision making. So that responsibility does rest on the PIC to be sure we are safe and ready to fly. Personal minimums can be helpful as well. A little different for drone operations. You may find yourself not quite as going through a great extent as you would with GA fixed wing manned flight operations, but still you may find yourself benefiting from setting personal minimums of I will not fly under certain wind conditions, visibility, or over certain terrain or things of that nature. So I'm going to invite Jim and Steve to talk more about this. Guys, what are your thoughts on this topic here as far as a pilot?
Well, the first thing is I noticed that 23% of our audience said that they are unmanned pilots only. And I would like to extend a warm welcome to what I lovingly call our new accidental aviator friends. And these are folks that have now jumped into the aviation world through unmanned aircraft that unfortunately have not had the same benefit of manned aircraft pilots, which is spending many hours in a cockpit with a flight instructor, or hanging out at the airport and learning from the old timers, or hearing lessons from other people about what they've learned. And so I feel like these sorts of events, getting people together and talking about these things, is a great thing for the unmanned pilot.
One of the first things that I kind of adapted from my manned aviation training into the unmanned world is the I'm safe checklist, recognizing things that can impact your fitness to flight: illness, medication, stress, fatigue. Have you eaten enough? Some of these really simple things, taken off with an empty stomach. It's easier to overlook when you're not thinking and engaging in complex activities like aviation.
Well, ultimately, the pilot is always the person who's responsible and in charge and liable, and he's the last person who has the decision-making capabilities to operate the flight safely and within the regulations. So it all rests on our shoulders, unfortunately.
Mm-hmm. Yeah, thank you, guys. All right, let's talk about the aircraft. There are no, unlike the manned aircraft come out of certification, there are no rigorous airworthiness certification process involved for drones. So there again, the responsibility, according to Part 107, that rests on the PIC to make sure your aircraft are safe for flight. And as we know, these drones come in all shapes and sizes. So you want to choose the right one for your needs and your proficiency level and your comfort level. It's really tempting, I'm sure, to go out and buy the expensive, drone right away, but it's best to start with the cheaper models and work your way up as you gain proficiency. So, Steve, Jim, what are your thoughts on this one here?
Jim?
Well, I'll let Steve, I know he's very passionate about this particular issue. Most of our audience is familiar with aircraft certification, at least to some degree, and it really boils down to testing and proving. So in order to be certified by the FAA, Cessna 172 and anything else that humans fly from the inside, has gone through a very long and grueling and exhaustive process of repetitive tests and basically proving itself. So by the time an aircraft reaches the market in the manned world, there's a lot of information about how long certain life-limited parts will last, what the overall reliability of the system is. And we have so far really nothing like that in the unmanned world. The drones that people are buying today that are available, so I'm excluding Defense Department equipment, but in the civilian world, there's nothing yet that has gone through a type certification process to the FAA. That is underway, that has begun, partly to facilitate package delivery and some of those other advanced operations. So it is coming. But in the meantime, you really don't have a way to predict reliability. And because of that, you're better off expecting failure and planning accordingly.
Yeah, the drones that are available for purchase today that are flown by even public safety agencies are built to no standard higher than a toy. There's no engineering requirement that they are airworthy. And this is actually a black hole in the Part 107 regulations, that a pilot has to determine that their aircraft is ready for safe operation. Safe operation is determined by if it meets the airworthiness requirements. There are no airworthiness requirements. So ultimately, as Jim said, we have to plan that the aircraft is going to fail, and we're going to talk about how often this actually happens.
Guys, we've seen a lot of advancements with technology in the cockpits of fixed-wing aircraft for manned flight. Is there anything on the horizon for UAS that's a technological enhancement, if you will, that we can look forward to in the future? Anything
Oh, absolutely. There are three things that I'm looking forward to. One is UTM, traffic management for drones, so that we can find the other drones in the sky, see and avoid type thing. The second is energy management. Right now, the drones that we fly are significantly limited by the amount of battery power they can carry. And there are advancements out there like hybrid engines, gas electric engines, and an opportunity for these drones to stay in the air for hours. And of course, the third thing is better types of control other than the rudimentary radio controls that we're using now to manipulate these. And that would include control over 5G cellular networks.
And that is likely to be a big part of remote ID, as it's called in shorthand. The FAA is likely by the end of this year, if not, or possibly a little bit into 21, we'll see. But they're going to finalize the remote identification and tracking rule for drones. So that is going for many, many operations today where you don't have to have any kind of a connection to the outside world. You're going to be required to network your flights in the future, probably over cellular. It remains to be seen exactly how that's going to happen. But that's going to have a lot of advantages as well as disadvantages. A lot of drones on the market today already have the basic hardware and can be, it's not going to be a huge burden, we hope, to retrofit those. And it's going to create a much better mutual situational awareness so that unmanned pilots, remote pilots will be more aware of what is in the airspace around them, and there may also be an opportunity for other airspace users such as emergency medical helicopters or crop dusters to tap into, to become more aware of nearby unmanned operations that may affect their flights.
One of the objections I hear from people who are only drone pilots is they feel like their privacy is being invaded with remote ID. The fact is that those who fly airplanes have had to deal with remote ID and have had the advantages of remote ID. And there is a track record of where we have flown and our speed and our altitude and everything else. And that's why this is a great time to really become familiar with the Part 107 rules, so that when your flights are tracked, you're always within the limits.
Steve, before I go to the next slide here, talk a little bit to those who are listening today and watching who have not flown anything yet. What could they expect to spend for an entry-level drone to get into this market?
There's a new, I'm not promoting any particular manufacturer. I think that you should look at all manufacturers. But an aircraft that has just come out is the new DJI Mavic, the small one. It's about $700. I really think that the less expensive aircraft right now are the best ones to have, because the higher end aircraft are, a year from now, they'll be half the price, and the new ones will be twice as capable. They are not an investment that is holding their value. And with the smaller aircraft, if you need to shoot 4K video or 4K pictures, a high resolution, do mapping, anything like that, you can do more now with a $700 drone than you could with a $15,000 drone 2 years ago. So shop by price and exactly what the features are that you need, and don't buy any more right now.
Steve wrote a great piece for Drone Pilot a few, I don't know, maybe a year ago about the Tello, which is a $99. I think it might still be on the market, but it was a very inexpensive system, and would be overlooked by a lot of particularly serious public safety users as a useful. They wouldn't look at it necessarily as a useful tool. But the utility of an inexpensive drone, and I've always urged anyone who doesn't have experience with radio-controlled aircraft or remote-controlled aircraft, the first drone you buy maybe possibly could and should be a $40 toy from Amazon. Something that has no automated stabilization, that's very much more challenging, frankly, to fly. But an inexpensive system, whether it's $50 or $100, can give you an opportunity to get used to the stick inputs and the flight controls. The most difficult, the most challenging part of learning to fly a drone, for me, as someone who had no background in radio-controlled model aircraft, was when the drone is flying away from you, it's relatively easy. The right stick goes right, left stick goes left, but that reverses as soon as you turn the drone 180 degrees, and now the head of the drone is facing you. And that takes time to get your brain adapted, and it's having a good comfort level with that is going to improve your safety, because if you fly drones for any length of time, sooner or later you're going to have that drone, that unmanned aircraft, close to a tree or a building or structure, something, and gusts of wind can push them around. And if you don't have that kind of pre-programmed instinctive response to correctly compensate for that wind gusts, well, you're going to be picking up pieces of your drone. So practicing with the cheap ones goes a long way to being more competent and safer with the more expensive systems.
My rule is, if you haven't crashed your drone at least 3 times, you're not a drone pilot.
All right, thanks, guys. Good advice. So for those of you listening in who are looking for some gifts under the tree this year, now's the time to take some advice. Maybe start off a lower end model and work your way up into this world. So good. All right, let's move along here. The environment. So we know that we're required by Part FAR 107 to do pre-flights, and we have operating limitations. It requires us to assess airspace and airports and whatnot, but it goes beyond that. So Jim, let's start with you. Let's talk about developing that big picture. What are some of the things we should take in mind when we're assessing the environment?
So when I start planning and developing a picture of the situation I'm going to be flying in before I even leave the house. Google Earth is a great tool for that. Satellite imagery can give you a pretty good general idea of the area that you're going to be flying in. So how many trees are there? Is the terrain, does the terrain elevation change a lot? What structures, utility wires, things to watch out for. So you begin building that picture before you leave the house. You can also use a number of weather products. That there are some specific to unmanned operations, apps. Manned aviation also gives us some very powerful tools for flight and other electronic flight bag apps. Can be a great source of weather information that'll give you kind of the bigger picture. And you'll know going in what you're up against. There are also apps for balloon websites and apps for balloon pilots that have been adapted to a degree for unmanned operations. And what that's going to give you is the lower level wind picture that is often not part of the manned aviation weather brief. So you can develop I have a kind of a set of tools. There are many out there, but I have a routine essentially that I go through to begin building a picture in my mind of what safety considerations, obstacles, what the operating environment is going to be like before I get there. And then when I arrive on site, I also make sure that I take a walk around the area that I'm going to be operating in and pay attention to overhead wires, trees, things like that. And I try to have in my mind as complete a picture as I can of what's out there. So if something comes up where I need to maneuver the aircraft quickly, I at least have some idea of what general direction it's safe to point it in.
This political season has been interesting because it seems like every day down here in Raleigh, North Carolina, we've had some sort of temporary flight restriction, some TFR with some VIP flying in. And so even tracking TFRs that are active or NOTAMs, especially with GPS jamming sessions that have been going on by the military, are important to keep aware of. If you're a manned aircraft pilot and you're using Garmin Pilot or ForeFlight like I use, it makes it easy to find that. But Jim has, it sounds like he has the advantage of being able to pre-plan exactly where he's going to fly. Since I'm flying for fire department and police departments, I don't get to know where I'm flying until the moment the call comes in. And so the thing I rely on most when I'm heading towards whatever's going to be my landing zone is my Mark 1 eyeballs and looking out the vehicle and determining what the weather is. And I am never hesitant about saying no about flying. If the winds are too high or the rain is coming down too hard, you should always have the confidence to say, no, I am not going to fly, because it goes back to the pilot in command. It's your responsibility to make those choices.
Good. Yeah, I think too, for manned flight, there's a tendency when you're new to that environment for student pilots to be more tactical minded, where we think more narrowly about ourselves and our aircraft and the flight that day, and we should, and then we'll carry that with us through all of our flying career. As we gain experience, we learn to stretch that viewpoint into more a strategic mindset of what's going on around me, how my flight impact not only myself, also others. Something goes wrong, and know what could happen there. We'll talk more about that during the emergency section. So thanks, guys, for expanding on this topic here. Let's go into the risk mitigation discussion. Certainly, we know that ways to reduce some of these risks involved, because there are always risks involved in any kind of flying we're doing. Training, of course, is the foundation. We get some good training under your belt. Proficiency then afterwards is maintaining and sharpening and honing and growing your knowledge and skills as a drone operator, and always expanding your skill set with maybe a newer and larger model of a drone to further expand your skills and to gain proficiency. Let's start off with Steve. Talk about anticipating what could go wrong and what to do in a case like that, and talk also about the next point of where a situation could change abruptly.
So as new drone pilots, we've heard so much exceptional marketing, so many great videos online, so much stuff from other websites about how miraculous the drones are. What you don't hear a lot is that they're going down every day. They're falling out of the sky because of a myriad number of issues. So I always like to stress that people fly with a military mindset, that they always prepare that the drone is going to fall out of the sky at any moment. And in an airplane, when something goes wrong, you have a little bit of time because you can glide, or in a helicopter you can auto rotate. You have a smaller bit of time, but with a drone you have almost no time when something goes wrong. And let me give you a real quick example. A drone pilot took off. He was hovering for 8 seconds, and then the drone 4 seconds later impacted the empty bleachers at a county fairgrounds. at 49 miles an hour with 10 times the kinetic energy to fracture a skull. And all of that happened in an extremely short period of time. So we always have to be prepared to, number one, react to any emergency, and number two, as Jim said just a bit ago, when he gets to a scene, he looks around, and one of those look around things is to figure out where you're going to intentionally crash your drone if it starts to get out of your control. And the FAA calls that a final termination point, so an FTP. So look where's a safe place to crash it.
Good. Jim, what are your thoughts on this? And Jim, can you also talk more about the last point there as far as external pressures and expectations?
Yeah, the pressure can come from the nature of the mission. Steve, as a public safety pilot, has experienced this in a different way than I have, because his customer, his client, the end user of the data that he's collecting, is probably fighting a structure fire and trying to save property, trying to save lives. It's a little different when most of the work that I've done is real estate photography, cinematography, shooting for television commercials, that kind of thing. And there you'll get a different kind of pressure. Then the end user is really looking to frame that perfect shot and get the right angle and lighting and everything else that goes into that. And they're not at all aware of things like roads. Now, this came up in rehearsal yesterday when I boldly said that Part 107 precludes flying over roads. And I went and looked it up last night, and it does, but nowhere in Part 107 will you see the words, "You are not allowed to fly over a busy road," or over a road. What it does say under 107.3.9, operations over people, is that you're not allowed to fly over people. And the exceptions include, it's a very short list, people who are under a fixed structure, protected by a fixed structure, or in a stationary vehicle. And that's how the FAA regulated that. So if you think about it, particularly, the busier the road, the less possible it is to overfly it without creating a very high probability that you're going to wind up violating Part 107. That happens more than I would like, just looking at the work product that's out there from the UAS community and training that I have gone through online, particularly for commercial real estate operations. One of the popular shots that everybody wants is a nice big wide orbit of the subject property, and in a densely populated area, it's virtually impossible to fly that orbit without overflying several busy roads and sidewalks and everything else. So it's the responsibility of the pilot to say no and usually there's another way to get the shot that the director is looking for. So you might have to get a little bit creative. You might have to fly from multiple locations and do shorter range flights and to capture the angles that you're looking for. So there are solutions. You don't have to just blindly fly over a road, but that's a good thing to avoid, because going back to what we said before, the reliability of these systems is pretty unknown, and you can pretty well expect failure even from the best consumer UAS on the market. So you're really setting yourself up for a bad situation if you start breaking these rules.
Let's talk a little bit about training before we move along in the presentation, guys. So here's a scenario. Holidays are approaching. Say, for example, I just received my Part 107 certification, and I received a nice drone for the holidays. I unpack it. I'm excited to go out there and fly it. What's the very first thing I should be doing to ensure at the outset I'm being as safe as I can be and building that strong foundation for safety? What's the first thing I need to be mindful of and do?
I say it's the rules. I mean, I've actually seen somebody unpack their drone from Amazon and then go up 2,000 feet just because they're excited. So understanding that the rules are there for a reason, and to fly within those while you're not familiar yet with flying a drone.
Beginner mode is programmed into DJI drones for a reason. It's a switch that you can toggle, and it will keep the aircraft at a lower altitude and not allow it to fly as far away from the home point. So this kind of walk or crawl, walk, run approach that applies in so many ways in our lives is a good way to approach unmanned aircraft. I spent a lot of time with my toy drone flying obstacle courses indoors before I ever flew outside. And that created it was an interesting challenge and a good skill development, but it's also, it's a good foundation for all the flying that I've done since.
So here's two things that I normally assign to people who are new at flying drones. Go to your local park and practice up, down, right, left, controlling the drone. Next, I want you to find something that is 75 or 100 feet from you, a tree. And I just want you to go out and fly around the tree without hitting it. So figure out how you're going to do that. Use the camera, figure out how you're going to get around an obstacle. And the next thing is, the most important lesson is I get somebody more than 75 feet away from the landing zone, I take the controller from them and I turn it off. They need to understand exactly what is going to happen in case everything fails. And if the drone is set up correctly, it is going to come back to where it took off.
Great. All right, let's go ahead and take two questions here from the audience. Jim, for you, Kayla's asking, what wind speed do you consider not flying? Is there a maximum wind that you consider?
That's a great question. It depends. It depends on the other risk factors that I'm dealing with. So generally speaking, 20 miles an hour is really pushing the upper limit. Particularly if there are higher gusts. Most of the DJI equipment that I've flown has a maximum speed of about twice that. And it's good to have a little bit of buffer. So if you think about how a drone controls itself, a drone that can fly 20 miles an hour forward speed in still air is going to get pushed around a lot more than a drone that can fly 30 miles an hour. So you have to take that wind speed and factor in, okay, if I'm flying downwind on a windy day, I got to make sure that I start bringing it back sooner than I otherwise would, because it's going to be fighting the winds the whole way back, and I don't want it to run out of battery. So, 10 to 15 miles an hour is going to be a range that doesn't bother most equipment. And in certain circumstances, narrow circumstances, but I've some friends of mine who I've trained with at the Center for Robot Assisted Search and Rescue have flown disaster response missions right after a hurricane blew through, and it was 50-mile-an-hour winds. That even you would not want to do that without having a lot of practice and experience. And there's a few tricks of the trade, such as dropping the drone to very, very low altitude to get it out of the worst of the wind that can allow you to bring it back. But I would say 20, if it's 20 miles an hour, that's pretty sporty. And anything more than that, it really depends on your personal minimums. And the other thing that you want to think about is what other risks you're up against. So if your operation requires flying farther away from the home point, than you usually would, understanding that we always have to maintain a line of sight on the aircraft. But even going, out to 600, 700, 800 feet downrange on a windy day is a much bigger bite of risk to be chewing on than it would be if you were, hovering around the home point, basically. So these kind of, risks are not I don't think of risks so much individually. It's kind of like a pile. And you start off with, you start adding up risk factors. And if that pile gets to a certain size, yeah, you either change the operation or you just scrub it. Some of the best decisions I've ever made as a pilot were decisions not to fly.
All right.
Let me follow up on that real quick.
Go ahead,
There's a
Steve.
public safety agency out on the East Coast that was doing a training flight, and they flew out over the ocean with the wind behind them on the way out, and they only made it halfway back before the batteries ran out, and they lost their $30,000 drone.
So when you consider wind, velocity, direction, and distance, good. Thanks, guys. All right, one more question. This slide here, then we'll move along, I promise. Steve, Craig's asking, what are some good characteristics of what to look for in a good night flight drone course?
Excellent question. So the first thing that you always have to look for is make sure that your drone is properly equipped for night flight, which means that it has strobe lights on it. But here's one of those gotchas, is that there is no manufacturer out there that can sell you a drone that is compliant with Part 107. You as the pilot have to self-certify that your drones meet the standards, being able to be seen for 3 miles. And how do you do that? You have a friend who goes 3 miles away and you take the drone up and they verify it and you can write that down. Outside of that, one of the best training tips I think I have for teaching night flying courses is training people during the day by having them put on a pair of foggles, instrument glasses that we hate and use for instrument training in the airplane, to restrict their view so that they get used to flying the drone using only the tablet and not relying on looking at it exclusively.
Good. All right. Go ahead, Jim.
The FAA has some pretty specific things that they look for when you're applying for a 10729 waiver, which allows you to fly an unmanned aircraft at night. So they want, the FAA wants to make sure that the remote pilot in command and the visual observer, and I've never seen a night waiver that did not require a visual observer. And the training is actually fairly straightforward. Much of it is available easily on the FAA website, and you can look up optical illusions and related effects that you have to cope with at night, such as your vision is going to be a little better if you're looking slightly off center at night versus during the day. Those sorts of things. Using the FAA, the way that I got my night waiver was basically using the FAA's own material, a couple of one or 2 page briefers on that subject, just to have general awareness, and that satisfies the FAA that you're aware that not only do you need to light up your drone so that it's visible for 3+ miles, and there are some pretty good strobes on the market that'll do exactly that. But they also want to make sure that everybody on the flight crew, pilot and visual observer, are aware that seeing at night is not the same as during the day.
Well, Jim mentioned the 107.29 waiver. In FAA wisdom, a night waiver is called a daytime waiver. But item number 10 in that waiver is another one of those gray regulation areas, which says that your entire flight operation area must be illuminated, or you must have gone out ahead of time and performed a visual inspection of your flight operation area during the day to look for hazards and obstructions. I don't know how you illuminate your whole flight operation area at night. So the bottom line is you just have to exercise common sense, say no to flying when it's not safe, and don't be in a rush to fly at night.
All right, good advice. Thank you, guys. Let's talk now about when things go wrong here, emergencies. So, Jim, walk us through some of the important things to consider during emergencies.
So when I first got into unmanned aircraft, I created my own checklists because since the 80s I've been flying manned aircraft, and checklists were a thing. And the manufacturer's material, this is back in 2015, not quite as robust as I wanted. So I created a custom checklist, and I tried to replicate tried to transfer a lot of the items that you would find on a Piper Cherokee checklist, and adapt them for an unmanned aircraft. And one of the big ones that we always have in the flip book in the airplane is the emergency procedures. And the emergency procedures checklist for manned aircraft can be quite long. A lot of it, it's good to memorize, but it's actually pretty short for an unmanned aircraft. The biggest thing is, the only thing that I think I wound up putting on the printed version was take a deep breath and thumbs off the sticks. Most of the once you get into the above the $50 toy level, most unmanned aircraft will self-stabilize. Now I'm talking about the multi-rotors. The fixed wings kind of fly themselves for the most part. So, but thinking of the typical multi-rotor drone, if you just take your thumbs off the sticks, it will hover in place, and you can take a few seconds to figure out, okay, what's the situation? How do I cope with this? So if you're seeing, and you can start to, begin to take the next steps, whether that's land right where it is or start to fly it in a, toward a safe flight termination point. But the thing that you don't want to do, the thing you want to resist is just taking some kind of abrupt action if you don't have a really good grip on the situation, because you're just as likely to make it worse as you are to make it better.
Yeah, very good. Steve, what are your thoughts on this?
Failures come in two varieties. One is a situation that is new to you, that you're unfamiliar with, that you're not trained for, and it's unexpected, but the drone is not coming out of the sky. The second is the drone's coming out of the sky. So when you have a mechanical failure, a propulsion failure on a drone, it's just going to fall like a brick, and there's not a whole lot that you can do about it. But if you have something where the drone is flying away from you, or you've lost, as Jim has told us about a story about where his tablet went blank while he was flying, and I think we've all had some of those. That is not something that is going to cause the drone to come out of the sky. So, as Jim said, do one thing, take a breath, do one thing, take a breath. And I see more new pilots crashing their drones by pushing the sticks quickly, instead of, as Jim just said, just relax, take your fingers off the sticks, and get a grip on exactly what the situation is.
It's also, I think, if you maintain a dynamic situational awareness throughout the flight, that's going to help you a lot if an emergency or an malfunction, anything abnormal comes up. So I make a point every few seconds while I'm flying, I go through this little mini checklist in my mind of where's the drone relative to me, what direction is it facing, and what's the overall situation airspace wise around me. And that interrupts the focus on whatever house I'm taking a picture of or whatever the mission actually is. It's a little break and do a quick sit rep check. And if you keep refreshing that picture from the start of the flight to the end of the flight, it'll help you respond more effectively and accurately and clearly if in abnormals, IMU errors have happened to me several times. I've had compass errors in the middle of a flight. Drone starts to drift in an unexpected way, and having that current, and Steve mentioned, I was flying next to the Connecticut River a couple of years ago on a January day in Inspire 1, and without any warning, the display went straight to black. And because I knew, where the aircraft was and which direction it was pointing, I could easily bring it right back to me without having to, pay any attention to the non-functioning display screen on top of the controller. So it turns having that constantly updated current picture in your head of what the situation is overall will dramatically improve your chance of coping with abnormal conditions.
And speaking of abnormal conditions, one thing that I use that is totally free and everybody has it at hand for monitoring your drone while you're flying. You're looking at the screen, you're looking at the drone, but I always use my ears and I'm always listening for, does it sound different right now? And that gives you an early warning, especially if the thing starts flying away. You know, you're attuned to listening to where it's going.
Yeah, that's good advice, Steve. And thank you, Jim, as well. Jim, what you said ties nicely into the last point here in FAR 10719. Earlier, we talked about the environment, becoming aware of the big picture before we go on a flight. Talk to me a little bit about loss control. I think when we think about drones, if we're new to it or haven't gotten into this world yet, we might think of, okay, if we lose control of a drone, it's going to come straight down. In many cases, that will happen, but these can also can veer off left to right, forward to backwards without control. Is there a certain guideline that drone pilots should be aware of, maybe a certain perimeter, if you will, that if you're a certain altitude, maybe be sure that the surrounding 200 feet perimeter around your flight is also safe from obstacles or people? Can you talk more about that a little bit? Any guidelines for people operating in that to be aware of loss control? Could not be just straight down, could go any direction.
Yeah, it depends a bit on the size of the unmanned aircraft and how fast it can fly, but you can visualize kind of a cone. So you know, with the unmanned aircraft at the top, and then extending both down and out to the sides is an area where it could possibly wind up in the event of a malfunction. And you kind of have to guesstimate. You're not going to measure this or have a really hard and fast idea of where it could wind up in the event of a failure. But bearing in mind, you know, if you think about, okay, as you're building that situational awareness picture, include in that awareness of what's directly underneath the drone, and choose your flight paths to and from the launch point accordingly. You can stay away from flying over sidewalks, avoid flying over roads. Be aware if there's a crowd of people in the public park that you might be flying in. Over there, that's a place that you want to give them as much space as you can, really. There may be times when you really want to get a picture or an image of this, you know, of some particular thing, but there's people around it. Well, maybe wait and they'll leave, or, you know, anticipate that somewhere in this, you know, upside down ice cream cone is this area of uncertainty where the unmanned aircraft could wind up. Quadcopters, you know, four-rotor aircraft, generally speaking, will not fly for very long if even one electronic speed controller fails. So they're full of these single points of failure that can bring down the entire aircraft. And when it comes down, as you pointed out, it's not necessarily going to come straight down. It might be spiraling. It might be launching itself off in a different direction. IMU, inertial management unit failures can have very unpredictable results. So, you know, you don't need a mile of buffer around a Phantom 4, but you want to be aware of not just what's directly below, but that cone-shaped area around the aircraft.
Yeah, you know, I think about it as kind of a target, a bullseye type thing, where the drone is the center of the bullseye, and then there are two rings. For me, this is just my personal thing. The first ring is what I call the recover ring, where it starts to get wonky and it's starting to fly away, and I'm going to try to recover it while I'm within that ring. And then once it passes whatever that threshold is, it's terminate. And I've had that situation where I had a drone just take off on me, and it was headed for a strip mall, actually. And I tried to recover it for about 30 seconds, and then I was sending it into the trees that was away from people.
All right, good advice from both of you. Thank you. Let's move on to some case studies here. Steve, some of these came from your website at reportdroneaccident.com. Talk us through these case studies, please.
So there was a pilot out there drone pilot who might not have had as much experience as he needed. and he was out flying his drone in a wooded area when all of a sudden a helicopter was approaching. He was at about 400 feet. The helicopter, the pilot said, came in at about 150 feet. It's important to know that both helicopters and manned aircraft can operate at those low altitudes. And what he did was he hit return to home to bring the drone back, which created a bigger conflict because he had set the return to home height at 450 or 500 feet, and the drone started coming back, and it wasn't eliminating the conflict with the helicopter. Eventually, he took manual control over it and lost it into what he believes is the picture of this mud sediment tank, trying to get it to fly home safely. The drone was lost, and it has some good lessons learned from this. That there are a number of things that can operate below the maximum height of the aircraft. Again, going to my free sensor, listening for an airplane or a helicopter is a good indication of some sort of conflict that's coming into your area. The automated identifiers that are on our tablets that show us about other aircraft in the area, sometimes they're very easy to tune out because they're alerting you to things using ADS-B or something else that is showing you aircraft that it's 10,000 feet above you. And so we kind of tune them out. So keep your ears open and listen for aircraft. The big lesson to learn in this accident is that hitting return to home and going home is not, I would say, less than half the time it's the right thing to do, because you need to get rid of the conflict immediately. As drone pilots, we have a requirement to see and avoid manned aircraft and other aircraft. And so the best thing to do instead of returning to home would have been just landing the drone immediately. It would have solved everything. If he had looked down with his camera and found a narrow opening, he could put the drone down. It would be much better than losing it or crashing it into the mud tank. And this is something, as a public safety pilot, this next bullet point, that I have to still deal with, even though I've been flying in public safety drones since 2014, is don't let adrenaline lead you to make bad choices. When something unusual happens, like a helicopter flies into your area, and it's happened to me, I've had to land immediately for a helicopter that came in below my drone, came into my area. And the hardest thing is when you get that wave of adrenaline that something is an emergency situation, an urgent situation, and making the right choice. And this is why it's great to practice these sorts of things. Aeronautical decision making and dealing with emergencies is a skill and a practice that I cannot understate.
Steve, one of our viewers asked, or he brought the topic, which I know you've already answered through the chat feature here, was about returning to home may not provide obstacle clearance coming back. Is that correct?
Well, that is absolutely correct. So the maximum height for your drone is 400 feet above ground level from where you took off. Everybody can set their return to home height at whatever they want. In my area in North Carolina, we have rolling hills, and our highest tree in the neighboring area is 150 feet. I set my return home height at 350 feet because number one, it's legal, and number two, it's going to be as far away as possible from every obstruction. And so I will take it up and know it's going to come back at 350 feet, and then it'll come back and land vertically. And that's also important if you're flying at night and you can't see any obstacles. The higher that you can fly, the faster you can fly, the safer you will fly.
Okay, good. Jim, what are your thoughts on this accident analysis?
I think return to home can be a useful feature. I would be surprised if it has solved more problems than it has created. It's improved a little bit on the technology side with obstacle avoidance sensors, automated obstacle avoidance, using a combination of sensors that allow the drone to adjust its flight path as it encounters things. Before that, it was pretty darn common. You could see, you could spend 5 seconds on YouTube and find a dozen clips where people initiated a return to home on the wrong side of the, with a house or something between where the drone was and where the landing point was. So I'm similar to Steve. I actually am a little, I set my return to home altitude typically a little bit lower. About 200 feet is 150 or 200 feet is a common one for me. It's part of my assessment of the operations area, is try to guesstimate the tallest obstacle or structure that's going to be in the flight environment that I'm flying in, and then add 50 feet to that. Going higher, does make sense, and it's in some respects, and it's legal. But going back to the cone that I was talking about, if you visualize the drone being on top of a cone, the higher you go, the wider the area of uncertainty is on the ground. So I prefer personally to balance a little bit the various uncertainties that are involved in case it is necessary to use return to home. We didn't talk about this yesterday, but I just occurred to me to throw out there with return to home. There's another way that it can bite you. I have flown quite a few hours now off of boats, and when your home point is on the water, unless the boat is extremely well anchored, it's likely to move. At least a little bit, even drifting over the course of a mission. So when your drone initializes, it's going to take the GPS and it's going to record the home point. You'll often hear an enunciation, the home point has been set. Well, if the home point moves and it's surrounded by water, it's a really good idea to make sure that you have a dynamic home point enabled, so that instead of returning to the exact spot where it launched, the UAS will come back to wherever the flight controller happens to be located. So that's another thing to keep in mind with this. All these automations, they can and do help, but you have to be thinking through what are the potential consequences of choosing this return to home method versus another. Most drones can be programmed to have different behaviors in the event that you lose the control link between the remote controller and the aircraft. So the default generally is return to home. And there may be some situations where you want to choose a different one, such as, you can program them to land in place, or you can program it to hover in place, which it will do until the battery runs out. So think it through.
So this may surprise some people, but with my public safety flying, every time I'm coming back to land, I always initiate return to home. And the reason being that and so I'm extremely comfortable and familiar with it. I know exactly how it's going to perform. But the reason being that, it's like flying an airplane. Oftentimes, the most dangerous part is the landing, because you're tired, you're fatigued, you've been very stressed. And so I use that as an opportunity to just gather myself for a safe landing and bring the drone back. We fly highly technical airplanes, and drones are highly technical. Let's use the capabilities where we can.
All right, thanks, Scott. Good takeaways. Let's go ahead and jump to the next case study here. Steve, walk us through number 2.
So again, the problem is that adding something onto your drone doesn't mean that it is certified, it's safe, it's operational, or anything else. A public safety agency was flying this Matrice 200 and wanted to put a parachute on it to protect people on the ground in case something happened. They had updated the firmware on the parachute the day before. There's no real way to test that. And so on the flight home, the parachute did exactly what you hoped that it wouldn't. It went off by itself, and when the parachute activates, it ejects the batteries out of the aircraft. So the drone fell from a height that was lower than the parachute could safely deploy and stop the drone from colliding with the ground. The drone was destroyed. And the lesson to be learned here is that just because you have added some component to your aircraft does not mean that it's going to actually stop the crash of the aircraft. Even with a parachute, you should always fly as if the drone is coming down. Other public safety agencies fire departments in major metropolitan cities agree that they don't add parachutes to their drones because they're always flying as if it is going to be coming down anyway. Parachutes can add any sort of component you add to your aircraft can create other complexities like more weight, reduced flight time, different aerodynamic characteristics. So never count on anything that you put on your aircraft to operate exactly as it should. You should always expect some sort of trouble if you upgrade anything, whether that's firmware, software, batteries, anything. You should flight test it all before you put it into operation out in the field. When there's a battery firmware out, for example, I'll take the drone out and hover it 2 feet above the ground until it runs out of battery power and see how it's going to operate. And remember that risks increase and situational awareness decreases with distance. So fortunately, this drone parachute went off as it was coming into land, but imagine if it had done that while it was out over a crowd. It wouldn't be good.
Yeah, good. Thank you, Steve. Jim, your thoughts on this?
I think Steve covered it pretty well. The following the manufacturer's recommendations for software updates and firmware updates is a really good thing to do. Usually when DJI pushes new firmware for a whatever model, there's a reason for it. It's fixing some kind of a problem that you may not have experienced yourself, but somebody else has. So overall, updating the firmware in the aircraft, in the batteries, will tend to increase reliability. But as Steve said, I also insist on making it prove itself. So anytime that there's a change in the system, fly it around for a little bit in a controlled environment, the backyard, the soccer field down the street, someplace where you can just focus on a very quick, it doesn't take long, but give it maybe half a battery of just flying around a little bit and make sure it's not going to do anything abnormal. It's not going to be 100%. You should still expect on just about every flight that something abnormal could arise. Something can go wrong, but if you're you can save yourself a lot of trouble with that. I like that hover 2 feet off the ground, especially when it comes to batteries, because that gives an opportunity for a gremlin to show itself, but you're not really putting the aircraft at risk, and you're certainly not putting people or property at risk.
Good. And I'll add to that second to last point there when it comes to expecting trouble, as we've been talking about throughout today's presentation, that it's not a matter of if trouble happens, it's a matter of when it happens, are you ready? And you need to be ready. And this can take place at any point during the flight. And we teach this to our manned flight students, not just emergencies on takeoff or just on landing. It's, are you ready for an emergency or a crisis at any point in the flight, and what's your backup plan? So good. Thanks, guys, for insight in that one here. One more case study, number 3, too far, too late. Go ahead and start us off, Steve. Walk us through this one here.
So this is also a great example of maybe some not so awesome aeronautical decision making. The pilot decided he wanted to see how far his Matrice aircraft would fly. The Matrice aircraft weighs about 15 to 19 pounds, depending on what the payload is that you've got on it. And if it falls from a height above 6 feet and it strikes somebody wearing a hard hat, it can be fatal using construction drop calculators. So we always have to be prepared that everything underneath it is at risk. The pilot, for some unknown reason, decided that he wanted to practice beyond visual line of sight flying without a waiver, a permit, or anything else. And he took off over a small metropolitan city. He flew 8,000 feet from his takeoff point, which was within 3 miles of a local airport. And on the way back, he experienced the same thing that seems like a lot of people say will never happen to them. He had a motor failure. The motors on the drones that we fly have no rating for the amount of time that they'll fly. I've seen these things fail after 5 hours, brand new out of the box. A motor will fail, and the drones are not designed. Some drones are getting more skills and more artificial intelligence to try to manage on 3 motors or 2 motors and try to bring it to the ground safely. But the vast majority of the drones that we fly, if they lose a motor or a propeller, they're just coming down. So he came back about halfway back, about 4,000 feet from his takeoff point. He had a motor failure and the drone started to come down. The only control that he had was to maneuver it to an empty lot to avoid hitting anything. But it was people and cars and buildings and structures and everything else that was below him, so he was lucky.
Okay, some lessons learned.
Well, again, Part 107 regulations might not always be sexy, they might not always be fun, but they're there for a reason right now. And the primary reason from all of the accident reports that I get is to protect not only you, your wallet when you're sued, but also people and property on the ground. There's no excuse for flying 8,000 feet from the landing zone, and it's impossible to defend 4,000 feet, crashing 4,000 feet from the landing zone. And when you are flying that far away and you don't have visual line of sight on it, your situational awareness is almost next to nothing. And if it is far away and you cannot see the drone, you're only relying on whatever telemetry that you have in front of you, and without visual awareness of the drone, your reaction time is not going to be enough to save it.
Good. Jim, your insights on this.
8,000 feet is a long way away, but it's not actually the record. If I were building a remote pilot hall of shame, I think Exhibit A would be the Phantom 4 pilot who collided over New York Harbor with a UH-60 Black Hawk helicopter that was patrolling for the United Nations General Assembly. If memory serves, that was well over 8,000 feet when that midair collision between the quadcopter and the Black Hawk helicopter took place. And the only reason we know anything about this is that a small piece of the DJI Phantom, the end of one of the motor arms, wound up inside of the helicopter. So they were able to eventually have a conversation with the owner, tracking it down through the parts identification number. At about 1,000 feet is about as far as I have ever, comfortably flown an aircraft up to the size of a DJI Inspire. The larger aircraft, you can see them in a meaningful way at a somewhat larger distance, but a couple of things happen when you're that far downrange. It becomes very difficult to determine the orientation of the aircraft at that distance, and it becomes very difficult to judge the aircraft's distance from other objects in the environment, including trees. Much less clear the airspace visually with your eyes. So you're not going to be able to have an accurate judgment of how close, if there is an incoming crop duster or medical helicopter, you're not going to have a really good appreciation of whether this is an emergent, need to cut the power and drop the drone now kind of moment, or if you have enough time and space to just land it to get out of that manned aircraft's way. So everything, the risks multiply with distance. Distance is one of the big factors that really hurts people. And the other thing to bear in mind is that it's very easy to lose the camera signal. So there's a tendency I've seen with a number of pilots, especially when you're first learning these systems, to rely pretty heavily on that first-person camera view, and that can be a trap. It can degrade your situational awareness of the airspace around your aircraft, and as mentioned earlier, it's also a fallible system. So if you're counting on that first-person view to know where your aircraft is in relation to that building or those trees or those people, Out at distance, it becomes, you know, exponentially more difficult as distance increases. So usually the best answer is to move your feet and is to recover the aircraft and then move to a different vantage point, so that whatever it is that you need to film or image or whatever data that you're collecting, you want to be ideally as close to the UAS as possible. I have used a practice that I informally to myself called walking the dog. For real estate shots in particular, very often there are trees or other inconvenient objects in close proximity to the subject that you are there to image. And it's actually very effective and easy to keep, you know, a very short range between. You just need to be out of the frame. So you can move yourself to reposition to be able to see visually the clearance between the aircraft and other objects in the environment. Though the caveat I will hasten to throw out with that is you don't want to be moving the aircraft and yourself at the same time. Pick one. So don't reposition yourself while the aircraft is in motion. You can hover it and then walk a few steps this way, and then, you know, return your full attention to the aircraft. But that technique is useful for obstacle avoidance. The longer range stuff, I really discourage that. Try to avoid that. There's almost never a really good reason to fly more than a few hundred feet away from the home point.
All right.
So one of the problems is that as you're flying away from the home point, the drone looks like it's getting closer to the ground and you can't judge the speed. So as a kind of a more intermediate training step, what I like to do with new pilots is help them to become instrument-rated drone pilots and fly by telemetry instead of relying on exactly what they're seeing. So one of the things that you can practice with is you can take the drone out to near where the edge is that you're comfortable that you can still see it, and then just fly it trying to maintain the same speed and the same altitude above the ground and see what that looks like. Because inevitably what people will do the further it gets away from them is they will start to fly faster and they will start to fly higher. And it's easy to get things out of control unless you're comfortable on understanding what you're seeing on your tablet.
Yeah, I'm sure. That's a good segue into our next slide here, recommendations. Steve, here we have some points set up here to recommend to pilots to operate drones safely. Talk us through some of these points, please.
There are two types of pilots. There are those that have had crashes and those that will. And you should always plan that something is going to go wrong. Next time you pull up at whatever your landing zone is, hopefully now that you've attended this webinar, we haven't talked to you out of flying. We've encouraged you to fly and fly better than every other drone pilot out there by looking for things like, where is my out? If something happens, where can I safely take this down? What is my final termination point where I'm going to crash the drone if I have to? And avoid flying over anybody or vehicles. There was an accident report that came out of the UK recently, and Inspire 2 is flying along very happily, and all of a sudden had a total battery failure in flight, and it came down and severely damaged the car that it hit, and it obliterated the drone. So you should always expect that gravity is going to always win. That's my rule when I'm flying a drone. Gravity always wins, and make sure that you're safe below. Be aware of the property below that could be damaged. Not only does that include people and cars, but also other things too. Like there have been some examples of drones coming down in very dry fields causing fires when the batteries erupt. And so be aware that there are other things that you might not have thought of. As Jim mentioned, when it comes to flying near your edge of your line of sight, I agree with him entirely, which is use your feet and move your landing zone and stay close to the drone. It is much smarter to do that. One of the problems here that we have is we have add-on products like drone mapping tools where you can program the drone to fly an automated path, and it's easy to let the thing get out of your line of sight when it's out there flying itself. And it's also easy to get distracted and not focus on it and have it crash somewhere where you don't know where it is.
Yeah, very good. Jim, what are your thoughts on this?
Pilots tend to be, I've always said pilots tend to be pessimistic people in that, we are trained in the manned aviation world to anticipate that failure. So when I fly an airplane across the country, I occupy my mind in between, radio calls and navigation checks by just kind of surveying the area around me and beginning to plan, well, if I lose the engine right now, that golf course over there would be an option. That cornfield may be better than that other cornfield because that one looks like it just got plowed. Those kind of things, and it's more about a mindset. The way that applies to unmanned aircraft is just anticipating failure, anticipating system failure, and figuring out, having a plan, already, having a decision already made, essentially, of what you will do when a helicopter or a Piper Cub encroaches or whatever arises, and bearing in mind that you can't always predict what is going to arise. But if you plan your flight such that you're not going to be overflying sensitive areas, people, things that can be damaged by a falling drone, that's really the best approach. That's going to not only it's about safety and following the regulations, but you can also wind up saving yourself some money by not having to go out and buy a new UAS, or not having to pay for that giant plate glass window you just flew through, or what have you. So the consequences include the potential for regulatory action if you have a Part 107 remote pilot certificate. The FAA can come after you for messing up. But more important to me, frankly, is I don't want to be the person that cripples this industry because I made such an egregious mistake that led to a catastrophic outcome. Unmanned aircraft are small, but as Steve pointed out, even a relatively small aircraft can do a lot of damage if it comes tumbling out of the sky and hits the wrong thing. So those being proactive and taking the time to really build a good picture in your head is the foundation of safe flying to me.
So I am a proud AOPA member myself, and one of my recommendations I give to all pilots is to go and look at the AOPA Pilot Protection Services plan that is available for legal protection, so that you can feel comfortable about, it's not that much money at all, so that you can feel comfortable about picking up the phone and asking questions with the experts there. And if anything does arise, you've got somebody who's got your back, and it's a great service.
All right, thank you for that, Steve. Okay, that's we're kind of nearing the end here. So if you're watching us, please, we have about 12 minutes left here in presentation. We're about wrapping up, but stay tuned. We got some more important information to share with you before we close out. So thanks for your patience. Let's talk about safety culture real quick here. This is just in general to walk through this, our thoughts and attitudes, behaviors of how we view safety, how we approach it. This involves everyone. So we talked already about these accidents taking place where the pilots, had some problems, and maybe they did not consider the world around them, the environment, the people below them, the cars, what could go wrong. So keep in mind, it's not just you, it's the entire flying and non-flying public around your operation that could be affected by the choices you make. Transparency and trust is very important. This is a budding environment, new, and for many years in manned flight, we've come a long ways from the earlier days of flying to where it was more of a weeding out process, and pilots who made mistakes didn't speak up, and they're afraid to approach those with higher seniority or more experience to question their ability to fly safely and question their behaviors. But we are in a new era now. We want to keep expanding this area here with safety culture to encourage drone pilots that if you have a problem or if you see someone else who is flying with questionable behavior, don't be afraid to tactfully and gently speak up and talk about the problem and talk about with fellow drone pilots to see how you can be a safer pilot, because that will ultimately lead to a better perception of drone flights for the non-flying public. And keep in mind, that's so critical. We go through this year after year, past decades with here at AOPA. It's so important that our messaging is honest and we're transparent, and we help all GA pilots understand their responsibility and their responsibility to completing that safety culture picture, if you will, so everyone looks favorably upon what we're doing here. So always learn and always be mentored to those who are learning with you. And then Jim and Steve, I want to ask you to talk about some takeaways here. Walk us through some of the key takeaways before we wrap up, if you would, please.
Jim?
Well, risk assessment, it's the big thing. Think about what can go wrong, visualize ahead of time, and figure out ways to mitigate risks. If your client or your friend or whoever is asking you to do something that's unsafe, don't be afraid to say no. That's your responsibility. That's what a pilot in command does, including a remote pilot in command. And also be sensitive to the fact that not everybody is on board with this whole drone thing. So don't antagonize the neighbor unnecessarily, buzzing their house. Simple good citizenship things can go a long way. And and take advantage also too of the community that exists online in various Facebook groups. Most of these aircraft have user groups specific to the Phantom or the Inspire or the this or the that. So that can be another really good source of information about people will discuss known glitches, known problems, and solutions. So you can learn a lot about the system that you fly by participating in those kinds of online discussions.
Great.
I try to be a good ambassador for the drone field, and the public has a lot of misperceptions about drones, like we can see in people's windows and all this other stuff. When somebody walks up and is interested while I'm flying, I do two things. Number one, I don't let them distract me from safe flying right now. I tell them that I will be happy to answer all of their questions as soon as I can bring it back to the ground. And then once I do, the second thing is I let them hold the control. I'll put it in the air. I'll let them move it right and left and see the screen. And inevitably, people walk away and they go, wow, I didn't understand all of that stuff. So each one of us can do a little bit to help further the comfort and understanding of this field.
Good. Yeah, thanks to you both. And I like the word ambassadors. And to those that are watching today, ambassador simply means we represent. So as a drone operator or a manned pilot, we represent all the operations in the industry. So what you do should reflect positively and have a positive influence on our operations as drone pilots and manned pilots. Very good. So let's take a few questions here before we wrap up, guys. Two questions. First one from Alex is asking, does anyone have some helpful guidance regarding large birds of prey, particularly curious and annoyed hawks? So we've seen these viral videos go on YouTube. Guys, we can't prepare for this, but thoughts about wildlife and how we treat these birds of prey that we've seen attack drones.
I mean, I've had a hawk dive on a Phantom in flight, and luckily I was able to scoot it out of the way, but the only thing I saw was just And this does happen. I mean, especially out here in North Carolina, we have hawks and other birds that take exception to the drones being in the air. And if they start to get too close, I land. I mean, that's the best thing that you can do. Birds, including seagulls. There was a seagull that took down a drone in England that crashed into the roof of a school. So they do happen. Situational awareness applies to birds as well as applies to planes and helicopters and other drones.
One of the more popular drone pilot stories this year was about the state of Michigan's Department of Energy. I forget the Eagle is the acronym.
Yeah.
It's spelled EGLE, and they were doing a shoreline erosion survey with a Phantom, and a bald eagle just swooped in and took it right out. They are. I have not lost an aircraft to a Raptor yet, but what Steve says is absolutely true. Your best bet is to land if they appear to be taking an interest in the aircraft. Often they will circle a little bit, kind of like sharks do, before they actually stoop and attack. So you might have some time, but that's another great reason to keep that situational awareness picture constantly refreshing. And maybe, if you have just be aware if you have nesting bald eagles or other large raptors like that. We're not sure whether it's territoriality or food or what exactly motivates them, but just assume that they're going to take a dim view to your unmanned aircraft.
In honor of Jim, this is my bird checklist. Nope. Land.
Yeah, they will win. All right, a few more questions coming in here, and then we'll wrap up with a few more slides here. All right, this one is for you, Jim. Is there any pressure, or for you, Steve, either one or both of you, is there any pressure to have manufacturers provide motor flight hour ratings and required maintenance schedule? What are other pilots using as a best practice to determine ongoing maintenance regimes?
As far as pressure goes, I don't know. The whole question about aircraft type certification is most likely going to focus not on the consumer systems typically flown under Part 107, but the delivery drones that are coming, that are being tested now and to be deployed in the future. I would be pretty surprised if you started seeing recommended replacement intervals for motors. There, some manufacturers in our space, in the smaller UAS space, will make recommendations on batteries, X number of charge discharge cycles. Batteries are one of the more common failure points in small unmanned aircraft. And we could have a whole webinar just on batteries, frankly. So that may be slightly a different thing, but I'm not. I would be kind of surprised to see that sort of information being widely available in the UAS space. There are services out there. Olaris Pro I've written about in the past comes to mind, where it's kind of a hybrid of a logbook and accessing Steve's reportdroneaccident.com website, where you can track your own maintenance and you can log flights, and you will also get alerts when other operators have issues with the same system that you're flying. But that's kind of hit and miss. And it's nowhere, as Steve mentioned a while ago, it's nowhere near as robust as what we would expect from the FAA and manufacturers in the manned aircraft space. So short answer is probably not.
Yeah, if I put on my pilot hat, I would say they should. If I put on my capitalist hat, I would say, why would they? Because the more they broadcast that there are these issues, it might slow down sales. And there's no regulatory requirement right now that they have to pass on service bulletins or airworthiness directives or any of this stuff, because they're not airworthy.
And the other downside to if they were to type certify smaller systems, the off-the-shelf stuff that we fly typically under Part 107, it would cost a lot more. So that $1,000 quadcopter that you can buy today probably increased by a factor of 5 in its price
Yeah.
if it were. So the trade-off, in a lot of ways, I think we're better off by taking this approach of good decision making, anticipating failure, and at the end of the day, replacing $1,000 drone is 5 times easier than replacing a $5,000 drone. So, risk versus reward, I think comes into play.
Okay, our time's almost up, guys. Thank you. 2 more slides here, then we're done for today's presentation. A few resources for you. We do have a decision-making safety center. This is basically a one-stop shop, web listing of different resources like online courses and videos, publications to help you improve your decision-making skills. Please, if you're not a drone member, please join aopa.org/go-fly/drones. A lot of great resources for you there. And keep in mind that AOPA, we're here to grow and preserve and protect the drone flying community. So good resources for you there. We encourage you to join. Other groups are out there as well, AMA, AUVSI, you can look those up online. And of course, Steve's website at reportdroneaccident.com. Please visit that website and go there. Hopefully not to report an accident, but if you do have an accident, please report it on Steve's website. So thank you for the resources here. So thank you to everyone for joining us today. Thank you to Steve and Jim for your time today. Great insights, good advice for the whole drone community. I've learned a lot of stuff as well, so thank you for your expertise. Just a reminder that everything we do here at ASI is through your generous donations to the AOPA Foundation. Now, we understand that right now with the coronavirus, many of you watching today may not have the means to contribute to our education funds. We understand that. We're just so grateful that you joined us today. So thank you for that. If you do have the means, please visit that website there at aopa.org/donate, and we'd appreciate any donation you can give to help us fund future education. Steve, Jim, any closing thoughts or advice for our group today?
Fly safe, fly happy.
Absolutely, I'll second that. And remember to have fun. I mean, as much as we kind of drill down a lot on taking a very serious approach to unmanned aircraft, one of the first things I learned that surprised me was the first time I flew a drone. It shocked me actually how engaging it was for the brain and how much fun it was, how much more fun it was than I assumed it would be as a manned pilot coming into this space.
Very good. All right, so there you go, folks. Fly safely and have fun. And thanks for joining us. And stay tuned for more webinars from ASI coming down the pike. In fact, there's one tomorrow night on carbon monoxide. So if you want to join us there, please go online to register for that. And we'll hope to see you soon. All right, everyone, take care. Be safe.